All right, hopefully you didn't have any issues with 9.1 and 9.2, and if you did have some questions or problems, you came to see me or saw some of your peers to get your questions answered. We're moving on to 9.3 and 9.4, which is about arcs and central angles of circles. So if we look at this, sketch a diagram of a bicycle wheel including spokes. Where do the spokes meet? So what does a bicycle wheel look like? So here's our bicycle wheel. Let's get rid of this part here. Then we have our center in there, and the spokes usually come out from the center. My pen's a little off, so they're not so even. So where do the spokes meet? They obviously meet in the center of the wheel. Choose any two spokes in your picture. Each set of spokes creates an angle. So if I choose these two spokes for my picture, they create an angle right here. Specifically, the angle two spokes create is called a central angle, because it's based around the center of the circle. So this right here is called a central angle. So a central angle of a circle is an angle with its vertex at the center of the circle. An arc, which might be new language to you, is an unbroken part of the circle. So look at this diagram. Consider circle O. Identify the parts of the circle. Okay, so when identifying the parts of a circle, you might go back and think, okay, well, O is the center of the circle, and OY or OX are the radius of the circle, and that's correct. So now we're going to add some more vocabulary words onto this. And one of the things that you just learned is YOX. So angle YOX is the central angle. Okay, now we're going to talk about arcs, because our other vocabulary word that's new today is about an arc. So it's an unbroken part of a circle. We have something called a minor arc, and then we have major arcs, or semicircles. So our minor arc is less than a semicircle. So in this case, our minor arc is XY or YX. But you have to put this little arc sign on top of it, the symbol, because that's the proper notation to identify that it's a minor arc. Notice that in a minor arc, only 2 letters are used. So only 2 letters are used here. 3 letters are used to name a major arc, because it's more than just a little small portion of the circle. So it's either more than half of a circle, or it's actually a half a circle, which is a semicircle. So in this case, we have major arc YZX, or you could say XZY, or we could say YXZ, etc. Just like up here on the row above, we could have said arc XZ, we could have said arc YZ, and these were also other possibilities for minor arcs because they're clearly less than half a circle. The measure of a minor arc is the measure of its central angle. So right here, if you have angle YOX and I name it to be 100 degrees, then this arc measure here is also going to be 100 degrees. So the measure of arc XY would also be 100 degrees, but we'll talk more about that later. The total measure of a circle is 360 degrees. So some of you might know that, but the total measure of a circle is 360, so you start at a specific point. If we start at X and go all the way around 2X, we would travel 360 degrees. The measure of a major arc is 360 degrees minus the measure of a minor arc. So obviously if there's only 2 arcs that we identify in a circle, then those 2 arcs need to add up to 360 degrees. Adjacent arcs. Arcs that are side by side. And if they're side by side, they must share exactly 1 point. So what are some examples of adjacent arcs up here? Well, we could say arc YX and arc XZ are adjacent arcs. Why? Because they both share point X. We could also say XZ and ZY. So there's a variety, or we could say ZY and YX. Those are all adjacent arcs. Congruent arcs are arcs in the same circle or in congruent circles that have equal measures. So an arc is congruent to another arc if they have the same measure. So going back up here, if I named this 100 degrees, and I put another one over here, and I said, oh, this is also 100 degrees, then suddenly we know that ZY is an arc that is congruent to XY. So it would be true that arc ZY is congruent to arc XY, if I identified this part right here. Now, if I said this was 100 degrees and this is 100 degrees, what does this last angle XOZ have to be? Think about it. Hopefully you're thinking in your brain 160 degrees, because then all the way around we would have 360 degrees around that circle. Okay, moving on. So we're going to practice. What I want you to do first is to pause if you haven't already and try to answer these on your own, and then when you think you've answered them correctly or you're finished, then go ahead and unpause and check your answers with me. Okay, so let's see how you did. Two minor arcs, that means those are the ones that are less than a semicircle or less than 180 degrees. So to me, it looks like we could have said AR, arc RC. You could have said arc AS or arc SC as well, right? So AS also works, or SC. For major arc, that has to be bigger than a semicircle. So a major arc looks like we could go, or just something that's a semicircle or bigger than a minor one. So we have AR, maybe ARS. All right, S, I would have to say actually that I would switch this to ARS. Well, the RCS works, sorry. The ARS and the RCS. So ARS going all the way around, so it's more than a semicircle. This one's not more than a semicircle. And then RCS, which is more than a semicircle. Two actual semicircles, right? So two actual semicircles. Well, if AC is a diameter, then that means my semicircles are ARC and CSA. So ARC and CSA or ASC, depending on which way you looked at it. An acute central angle, looks like this is my only acute one because this looks like it's bigger than 90 degrees. So therefore AOR, angle AOR or ROA would be my acute central angle. And then two congruent arcs. The only two congruent arcs we're going to have in this scenario are semicircles, because there's no other points indicating otherwise. So that's why I relisted my semicircles. Okay, now let's move on and try to find some measurements. So again, look at this problem, try to figure it out, pause now, and then come back to it when you think you're done. Okay, hopefully you got 100 degrees for A, 50 degrees for B, and 210 degrees for C. And if you didn't, let me explain it to you now. So arc WX. Well, the only way you can know an arc measure is to know its central angle. So remember, a central angle goes through the center of a circle. Its vertex point is at the center of a circle, and it opens up to create an arc. This arc measure is the same measure as the central angle. Well, you're probably asking, how did you know this is 100 degrees? Well, if you see in our next arc, then WT is 50 degrees, therefore this angle must be 50 degrees right here. And if this is 50 degrees and this is 30 degrees, well, it says over here that YT is a diameter, therefore from Y to X to W to T, this is a semicircle. And a semicircle is equal to 180 degrees. So that means, we get a better color, that 30 degrees plus 50 degrees plus x degrees equals 180 degrees. Therefore, I can see that x, or in this case, I'm talking about this angle, is 100 degrees. And if this central angle is 100 degrees, that means the arc must also be 100 degrees. Now with that work, I then identified the fact that angle WOT is 50 degrees, and you saw why, the central angle arc measure. And then finally, we're going to do this outside part from x to y to t. So I'm talking about this outside arc right here. How do I know how big this is? Well, from y to t, it's 180 degrees because it's a semicircle. And from x to y, it's 30 degrees because that's a central angle. And 180 plus 30 is equal to 210. Therefore, arc XYT is 210 degrees. If you have questions about that, make sure you ask me before you move on. Or ask me in class because you're watching this at home. Okay, next, use the given diagram to find the measure of each arc. Whew, how are we going to do that? All I see here are variables. Okay, think about it, press pause, and I'll give you a hint if you're stuck. Think that all the way around the circle is 360 degrees. So what can you do? Go. Okay, so you might have gotten 88 degrees for arc AB, 52 degrees for arc BC, 38 degrees for arc CD, 104 degrees for arc DE, and 78 degrees for arc EA. If you didn't get that, then let's figure out how you can. So the hint I gave you before you pushed pause was that all 1, 2, 3, 4, 5 of these angles, central angles, should add up to 360 degrees. Right? So remember I said that right before you pressed pause. So if we add up all 5 of those angles, we should get 360 degrees. So 3x, 3x, 4x, 2x, and 2x is 14x, positive 10 and negative 14, I don't know where that 1 went, is equal to negative 4. So when you solve, you get x equal to 26. So then you just start plugging this in. X plugged into here, plug it into here, plug it into here, and then you solve for the angles, and this is what you get. If you're not sure if you did it correctly, the last thing you can do is add them all together. Do they, it's a little question mark, do they add up to 360 degrees? Yes, they do. Therefore, you've just made sure that you have 100% on that question. Okay, now we're moving on to 9.4. So 9.4 is going to take some independent work here. Cut out a circle, use your ruler, do some different things, and then try to fill this in. If you don't have these things at home, then you can wait and do this in class, but otherwise you can just try your best at home and see how it goes. So push pause now and try it. Okay, after you went through that activity here in Investigation 1, you should have discovered that congruent arcs have congruent chords, right? So you were to cut this off, put it somewhere else, make the same arc, and this arc must be the same as this arc, and these chords therefore must be the same length. So congruent arcs have congruent chords, just as congruent chords have congruent arcs. Moving down to Investigation 2, if you already did that, or if you want to stop and do that one, then you can figure this out after, or if you already did it, then you can see the answers now. So a point Y is called the midpoint of XYZ, of arc XYZ. So a point Y, so if we have an X, a Y, and a Z, point Y is the midpoint if arc XY is congruent to arc XYZ. I don't really think you can put those marks like that, but we know them from segments. So therefore, any line, segment, or ray that contains Y bisects XYZ. So if I have a line that goes through, that means it's going to bisect arc XYZ. Investigation 3, do this one on your own, then figure out the theorem. So push pause now if you want to do it on your own and you haven't yet. Or if you've already done it, you can go ahead and move toward the theorems. So a diameter that is perpendicular to a chord Okay, so here's a circle.